This is the rock at the center of a historic NASA announcement this month. Inside these dark, organic structures, the Perseverance Rover has found what scientists are calling the most compelling evidence for ancient life ever discovered. Here is the moment from the press conference where they revealed their findings.
Listen, we can't find another explanation. So this very well could be the clearest sign of life that we've ever found on Mars, which is incredibly exciting.
A potential fossilized ecosystem. It's a claim that could change our place in the universe forever. This leads us to the most important questions of our time. 1. What is the stunning evidence inside this rock that points to a fossilized metabolism? 2. Why is this discovery succeeding where all previous claims of Martian life have failed? And 3. What happens now in the epic, multi-billion-dollar race to bring this rock home for the final verdict? First, the location. The choice of Jezero Crater wasn't an accident. It was the result of a decades-long strategy. Perseverance didn't just follow the water. It was dispatched to a pre-vetted site with the highest possible chance of preserving ancient life. Billions of years ago, this was a massive lake, fed by a river delta. The rock itself is a sedimentary mudstone. This means it was formed slowly, over millions of years, as the river deposited layers of fine silt and minerals onto the muddy lake bed. As more layers settled, their weight compacted the layers below, and as the lake eventually dried up, the sediment hardened into stone. It's this exact process that traps and preserves fossils on Earth. Orbital scans confirmed this delta is rich in clays and carbonates, minerals known to be exceptional at preserving the delicate organic molecules of life. Even more exciting, at around 3 billion years old, this is some of the youngest sedimentary rock the mission has explored, suggesting the window for a habitable, water-rich Mars could be far wider than we previously imagined. This brings us to the rock itself, Chayava Falls. The rover's cameras spotted strange, organized textures, tiny circular poppy seeds, and larger patterns called leopard spots. And to be clear on the scale, even the largest spots are just 1 or 2 millimeters across. Any life here would have been microbial. The rover's analysis revealed these spots are packed with 2 specific iron-rich minerals, vivianite and greigite. But the bombshell from this month's announcement is what they were found with. The Sherlock instrument confirmed these mineral spots are spatially co-located with a strong signal of organic carbon. The rover has found the potential chemical waste products of life sitting right on top of the fuel for life. This is the signature of a metabolic process. In simple terms, this could be the fossilized byproducts of ancient microbes, eating, breathing, and living in the mud of an ancient Martian lake. The science team knew immediately how significant this was, even commemorating the moment they drilled a sample with this historic self-portrait. Now you'll hear NASA using very careful language, words like potential and compelling, but not definitive. Why? Because, as Carl Sagan famously said, extraordinary claims require extraordinary evidence. And science has been here before. The inconclusive results from the Viking landers and the intense debate over a famous Martian meteorite found in Antarctica taught the scientific community that you must first rigorously disprove every other possibility. So let's look at the non-biological explanations. First, a high-temperature reaction. Could hot volcanic water have created these spots? The geology shows no signs of the rock being baked. More importantly, the vivianite itself is a delicate, hydrated mineral that is destroyed by high heat. Its very presence acts as a geological thermometer, telling us this rock has had a gentle, low-temperature history. Second, an acidic water reaction. We know Mars had acidic periods, but the rover also found a mineral called olivine in the same rock. Olivine dissolves in acid. Its presence is a definitive litmus test, telling us the water here was likely fresh, with a near-neutral pH, far more conducive to life. With the most common abiotic explanations failing to match the evidence, the biological theory remains the strongest hypothesis standing. This announcement doesn't end the story, it begins the most exciting chapter. The consensus from the science team is clear. The instruments on Mars have taken us as far as they can. To get the final answer, we must bring the sample home. This makes the Mars sample return mission suddenly the most important mission in the world. On Earth, scientists can perform the definitive tests, like isotopic analysis to look for the atomic signatures of life, and chirality tests to see if the organic molecules have a unique handedness, one of the most unambiguous signs of biology. And it's now officially a race. Facing budget debates, the NASA-led mission is being challenged by China's Tianwen-3, scheduled to launch in 2028 and return samples by 2032. This month's news has lit a fire under the global scientific community. Who will be the first to bring home the proof? So what does this news mean for the world? It means we are living through a profound moment in our history. The line between science fiction and scientific fact has never been blurrier. The evidence is not yet definitive, but the question of whether we are alone in the universe has fundamentally changed. We now have a target, a sample, and a location. All that's left is to go and get it. And speaking of Mars, what about that massive interstellar comet, 3I Atlas, that was supposedly on a collision course with the red planet? Was Mars really in danger? You can find out the full incredible story by clicking on our video. To stay up to date with the latest analysis and the race to return the Mars samples, make sure you are subscribed and have notifications turned on.